Good morning, everyone. I'm Anthony.
I'm Michael.
I'm Bjornar.
And I'm Zachary.
And our project addresses a critical issue, the leakage of carbon dioxide from storage sites and its disproportionate impact on rural farmers and indigenous communities. Many of these storage sites are located near farmland, and when CO2 seeps into the soil, it disrupts plant growth, contaminates water, and harms local ecosystems. This problem doesn't just affect the environment, it threatens food security and ways of life. Communities that rely on agriculture are especially vulnerable, as CO2 leakage damages soil health and reduces crop yields. Our project was made to solve the carbon sequestration grand challenges, which focus on finding safe and sustainable ways to store carbon. We developed a method to turn captured CO2 into a solid construction brick. These carbon capture bricks lock the gas safely inside, preventing it from leaking into the soil, while also creating a useful building material. By transforming a harmful emission into a valuable resource, our solution protects the environment and supports the communities most affected by climate change.
Let me start by explaining the problem. Damage to farmland from CO2 leakage creates serious economic and environmental risks. Research by May and others in 2020 shows that when CO2 diffuses into the soil, it can negatively affect soil fertility, harm crops, and lower yields. This is especially damaging in rural regions that depend heavily on agriculture. When farmland productivity drops, farmers' livelihoods are threatened. These impacts can spread across the landscape, harming soil health and overall ecosystem function. Rural communities are often hit hardest because they rely directly on the land and they have fewer resources and less of an ability to respond to the contamination that comes from technologies they don't have control over. If you look at Figure A, you can see a topographical map showing the CO2 concentrations across the area. The darker regions represent higher concentrations, and you can see that the levels vary significantly across the landscape and aren't always predictable. In Figure B, it shows that CO2 concentration changes with soil depth. This helps us understand how deeply the gas penetrates and how it may affect ecosystems and soil processes. Together, these visuals highlight the seriousness of CO2 leakage and why understanding its spread is essential in protecting farmland and rural communities.
Our solution focuses on turning captured carbon dioxide into usable construction materials. As shown in Figure C, the process integrates carbon capture directly into brick manufacturing. Here's how it works. We start with bricks made from calcium hydroxide. These bricks go into a system that filters carbon dioxide from the air. That carbon dioxide is then pushed through the brick's internal channels, as illustrated in Figure D, where a reaction converts the calcium hydroxide brick into a calcium carbonate brick with water as a byproduct. This permanently locks carbon inside the brick while strengthening the material. The end result is a carbon-negative brick that functions just like a traditional one in construction. So, our approach tackles two problems at once. Removes carbon dioxide from the atmosphere, and it turns that captured carbon into a practical, sustainable building material.
This innovation fixes the problem with carbon leakage affecting rural and indigenous populations by changing the way we store carbon dioxide. We're moving away from temporary storage now. The solution involving storing carbon dioxide in bricks locks it away permanently and also makes it usable to be reused as valuable building resources as well. The carbon captured bricks are undeniably a great way to store carbon, but however, currently they are too expensive. To be precise, they are about 100 to 120% more expensive than regular bricks that are used today, which makes it very unappealing to use in construction. The solution to this and the goal would be to make this whole carbon capture process less expensive, also making the bricks less expensive and more attractive in the use in construction work as well.
Thank you for listening to our presentation.